Good morning. This is Hope Reactor. Now, let's begin today's news.
What if one of the keys to cheaper eel was not a bigger fish farm, but a tiny organism used to make bread and alcohol? Yeast. Japanese researchers have found that a special type of yeast could help farmed eels gain weight much faster. And that is only the beginning. The same idea could also help protect water quality, change the ratio of male and female eels, and even turn unused materials like saccharies into a new resource for aquaculture. So how can something as small as yeast make such a big difference? This is Hope Reactor. Eel is one of Japan's most famous foods, but there is one problem. It is expensive. For eel farmers, raising fish takes time, and every extra day costs money. They need feed, they need electricity, they need equipment. They also need to control water temperature and keep the water clean. One important ingredient in fish feed is fish oil. Fish oil provides valuable nutrients that help animals grow, but fish oil also has disadvantages. It can become expensive, and if oil separates from the feed and spreads into the water, it can contribute to poorer water conditions. So researchers began looking at the problem from a completely different direction. Instead of simply mixing oil into the feed, what if they could put the oil inside another living organism? That organism is yeast. Researchers at Tokyo University have been studying a special type of yeast that can store large amounts of oil inside its own cells. Think of each yeast cell as a microscopic container. The oil stays inside the yeast, and the entire yeast cell can then be mixed into eel feed. There is no need to remove the oil first. The yeast itself becomes part of the supplement. But does it actually work? Researchers prepared yeast containing different amounts of oil. They then fed the yeast to eels 3 times a week for about 5 months. The result was striking. Eels that received the yeast with a higher amount of stored oil gained weight at about twice the rate of eels that received yeast with less stored oil. Their bodies also became thicker. But there is an important detail. The eels did not become twice as long. Researchers did not find a major difference in body length. The big change was in weight gain and body size. That distinction matters. This does not mean an eel suddenly reaches full size in half the normal time, but it suggests that changing the feed could make eel farming more efficient. And in aquaculture, efficiency can have a major impact. Imagine reducing the amount of time needed to produce a healthy, market-ready fish. That could mean lower feed costs, less energy use, and lower operating costs. In the future, that could potentially help make eel more affordable, but this technology is still being studied. It does not mean eel prices will suddenly fall tomorrow. Researchers still need to understand how well the method works on a larger commercial scale, how much the yeast costs to produce, and whether the results remain stable in real fish farms. Still, the idea is powerful. Instead of building bigger farms, you improve what the fish eats. And there may be another benefit. Because the oil is stored inside the yeast cells, it may be less likely to spread directly into the water. That could help reduce some of the water quality problems associated with oily feed. Researchers have also observed fewer bacteria in tanks where this yeast was used. Scientists are now investigating how the yeast may interact with bacteria inside the eel's digestive system. So this tiny organism may not only affect growth, it could also influence the environment in which the eel lives. And then came an even more surprising result. Among eels that received the oil-rich yeast, about 34% became female. This is unusual because farmed eels often develop predominantly as males. Why does that matter? Female eels are generally considered to have softer flesh. If researchers eventually learn how nutrition influences sex development, it could create another useful tool for aquaculture. But there is still a mystery. Scientists do not yet know why the percentage of females increased. So this does not mean feeding yeast will automatically produce female eels. It is an unexpected result that researchers now need to investigate. And the story gets even more interesting. The research team is also exploring ways to grow this useful yeast using materials that might otherwise have limited value. One example is saccharies, a byproduct created when Japanese sake is produced. Another possibility is leftover material from seaweed. The idea is not to feed seaweed directly to eels. Instead, unused resources could help grow the yeast. The yeast stores useful oil. The yeast is then added to fish feed, and the fish uses those nutrients to grow. Waste becomes a resource. That resource helps create food. It is a small circular system with potentially large consequences, and eels may only be the beginning. Researchers are considering whether similar yeast-based supplements could eventually be used for other fish, ornamental fish, livestock, and possibly even nutritional products for humans. A technology that started with a microscopic organism could influence several parts of food production. When we think about making expensive food more affordable, we often imagine bigger farms, faster machines, or massive new facilities. But sometimes, the solution is almost invisible. A tiny yeast cell storing a tiny amount of oil. Multiply that idea millions of times, and it could help change how animals are raised. Faster weight gain, potentially cleaner water, a surprising change in female eel numbers, and even a possible use for materials such as seaweed. This research is still developing, but that is exactly what makes it worth watching. The future of aquaculture may not come from something bigger. It may come from something we can barely see. Would you eat an eel raised with this kind of yeast supplement? And if it helped make eel more affordable and sustainable, would that change your answer? Tell us what you think in the comments. At Hope Reactor, we explore Japanese science, technology, and ideas that could turn today's discoveries into tomorrow's hope. If you enjoyed this story, please subscribe and join us for the next one.